And I know, Mr. Hartman, that you have a pretty lengthy testimony will be submitted in the record. As I said before, paraphrase as much as you possibly can.
Sure.
Okay, thank you very much.
Thank you, Chairman. Chairman Cristani, Senator Galvin, other members of the Senate Environmental Conservation Committee that will see our testimony, thank you for the opportunity to address you today on the matter of produced water and drill cuttings disposal as it relates to natural gas drilling and hydraulic fracturing. My name is Paul Hartman. I am the Director of State Government Relations for Chesapeake Energy Corporation. Chesapeake Energy is the second largest producer of natural gas, a top 15 producer of oil and natural gas liquids, and the most active driller of new wells in the United States. Due to time constraints, my testimony today will focus on Chesapeake's water recycling and reuse program, Aqua Renew. And I'm very pleased to hear today environmental advocates advance water recycling as a major solution to the water issues. It has been an issue of major concern to the state of New York and to the industry as a whole, and I hope to illustrate today how we have approached to solve the water disposal problems. Water is an important and highly valued resource, and Chesapeake takes its use very seriously. One of the major advances in the process of developing our natural gas resources in recent years that has resulted in significant conservation of our water resources is the advent of recycling and reuse of flowback and produced water by the industry. Water recycling, particularly in neighboring Pennsylvania, has been transformed from a trend to an essential operation procedure. Recycling produced water reduces the impact on local water supplies, which translates into less truck traffic, which means reduced road infrastructure wear and tear from water tanker trucks. Founded on the concept of water recovery and reuse, Chesapeake's Aqua Renew program is utilizing state-of-the-art technology in an effort to recycle produced water. This naturally occurring water is generally laden with various minerals that travels from the producing formation through the wellbore to the surface with natural gas during the completion and production operations. The quality of produced water, as is mentioned earlier by others that have testified, differs greatly with the varying amounts of salt, sand, or silt, depending on the formation from which it's found. Due to its normally high salt content, reuse and completion operations had been considered impossible by the industry for a very long time. Chesapeake began to intently focus on water reclamation and conservation after the 2006-2007 drought in the Barnett Shale in Texas. The drought had an obvious effect on Chesapeake's drilling and completion activities as well as surrounding communities. From that experience, Chesapeake's involvement with the Barnett Shale Water Conservation and Management Committee, the company entered into an agreement with the city of Fort Worth to study evaporation systems as a potential way to reduce the amount of produced water being injected into saltwater disposal wells, which was the preferred disposal technique at the time. Using an evaporative reduction and solidification system to capture heat generated by natural gas compressor stations, an energy source that would typically be wasted, a portion of the produced water is then filtered and reduced to water vapor. The resulting clean vapor is then released into the atmosphere where it enters the normal hydrologic cycle. Since this preliminary reclamation project, Chesapeake's focus on reuse of water has become a company-wide endeavor, stretching from the Barnett Shale in North Texas to northern Pennsylvania. In fact, the Aqua Renew program is helping to change the long-standing industry assumptions that produced water is unusable. As referenced previously, it was a long-standing supposition that using anything other than fresh water would harm the ultimate productivity of the well. As a result, operators had previously only used freshwater resources in drilling and completion procedures. Chesapeake decided to challenge and test that theory and see if it was true or if there was in fact a limit as to how much recycled water could be used without compromising well production. At each well site, produced water is collected and stored in on-site holding tanks before being transferred to a central filtration location. Our current methods of fluid treatment use both chemical and physical methods. The fluids from our drilling operations are treated through a filter press, which requires some chemical additions to adjust fluid parameters such as pH. Aqua Renew also uses fluctuating agents to assist in removing solids from the fluid. The physical treatment utilizes a washable system which filters out the suspended solids larger than 20 microns. The filtered water is then either stored in on-site tanks or transported to the next well scheduled for hydraulic fracturing, commonly referred to as fracking. The water is tested for salt content, total hardness, to determine at which rate it can be blended with fresh water to ensure proper quality and quantity for reuse. Chesapeake still has to mix the recycled produced water with fresh water in order to ensure the proper mixture for fracturing. But every gallon of produced water that is filtered and reused is one less gallon of water that has to be permitted at a disposal location and one less gallon of fresh water that has to be sourced. To date, Chesapeake still has not found a limit on the reuse of recycled water. In fact, the company's northern and central districts of the Eastern Division operations are treating and recycling 100% of the initial produced water from the flowback process. We believe that water can be recycled indefinitely as it's mixed with fresh water during the fracturing process. The fracturing process uses an average of 6 million gallons of water per well, depending on several factors. Through the second quarter of 2011, Chesapeake had 4 Aqua Renew sites recycling, drilling, and production fluids in Pennsylvania under an OG 71 permit issued by the Department of Environmental Protection Oil and Gas Division. This past summer, the Commonwealth changed the permit requirement to require a new permit, the WMGR 123, which is managed by the Waste Management Division of the Pennsylvania DEP. All future fluid processing sites will require an MRG 123. I have included a copy of this permit with my testimony for your reference. The OG 71 permit will remain available in Pennsylvania. However, allowable activities under this permit will be limited to the utilization of the recycled water on the well pad at which it was processed. Chesapeake has established a program of periodic measurement of the radioactivity of the recycled water and has found no increase in radioactivity over background data. We also measure the radioactive level of every load of solids which has been filtered from the produced waters as required per our permit, and have found no load of solids which exceed the limits set under the state operating limit. Currently, all filtered solids are trucked to a rail siding in Moshepen, Pennsylvania, and taken to Ohio for disposal in the landfill. The filtered solids are once again checked for abnormal radioactivity at the landfill before final disposal. On average, this process is able to filter and reuse more than 10 million gallons of produced water a month in the Marcellus Shale. In 2010 alone, Chesapeake recycled 83 million gallons of produced water. With such large volumes of recycled water, the company is seeing more than just environmental advantages. Our accounting department has estimated that this aspect of the process is saving an average of $12 million a year in the Eastern Division alone. The program is garnering results like these throughout our shale plays, and subsequently the Aqua Renew program is expected to continue to grow. Chesapeake is always evaluating new technology on our own and through partnerships like the one we have with the Barnett Shale Water Conservation Group and others. Currently in Pennsylvania, our biggest challenge to enhancing our recycling and reuse efforts is obtaining the permits for the development of additional fluid processing sites and avoiding the potential for exceeding current filtration capabilities. However, I must take the opportunity to appeal to the committee that innovation and technological advancement are only possible through a flexible regulatory and statutory regime that does not lock industry into yesterday's technology, best practices, or common practices. In April of this past year, the Pennsylvania DEP requested that all natural gas operators cease delivering wastewater from shale gas extraction to permitted wastewater treatment facilities in the Commonwealth. Chesapeake and all operators active in the Marcellus Shale Coalition have made extensive efforts to meet that objective, predominantly through the expansive reuse and recycling of produced water. Meeting the goal of near universal recycling and reuse can be impeded by burdensome and overly prescriptive regulations or legislative stipulated best management practices. I would advise the committee to examine the overall impact of any new proposals in regards to wastewater treatment, recycling, and reuse to determine the effectiveness of the policy and the creation of any additional barriers to sound water management and conservation practices that have been developed by industry leaders such as Chesapeake over the past several years. Please keep in mind that only 5 to 6 years ago, the conventional wisdom dictated that produced water could not be recycled and reused. And today in our Marcellus North operations, we are in fact recycling and reusing 100% of the initial produced water from the flowback process. In closing, it is with great pride that Chesapeake can share with you that the filtration recycling process we are utilizing is working quite well in Pennsylvania. The utilization of recycled water in our fracturing process has not had a negative impact on well productivity, and our fluid waste treatment capability creates a closed-loop system which has no impact on the fresh water, rivers, and streams in Pennsylvania. I thank you for the opportunity to address the committee today on this important issue. Please rest assured that Chesapeake stands ready to assist the chairman and members of the committee on this and any other issues pertaining to the responsible development of our natural gas resources.
Thank you very much. Do you know if other oil and gas companies are being somewhat as your company is with 100% recycling?
There are a number of companies that have achieved 100% at this point in time. As of the directive from DEP regarding disposal of public wastewater treatment facilities, I believe the industry was at about 70% industry-wide recycle and reuse. That number has increased dramatically. I don't have the current figure, but it is well north of 70% at this time.
All right, and then if you're recycling the water, at some point there's got to be an end product, correct?
The end product that we have right now is the solids that are filtered out, and those are disposed of at landfills.
Okay.
We currently are evaluating the effectiveness of the water in the reuse of the refracturing. At this point in time, we don't see a time where that water is not going to be useful for us for that purpose again.
Okay. The solids being disposed of landfills. Are you still disposing in Ohio as well?
Yes.
Okay.
We are disposing a little bit of our produced water from our southwest Pennsylvania operations in Ohio.
Okay. And you saw, I mean, you were here earlier, and when you saw like the open pits as far as what they're talking about and the cuttings, this is besides the frack water. What are you doing with regards to cuttings and so on and so forth?
We use a full closed loop system for our flowback water as well as for our drill cuttings. So we are operating on that closed loop system currently.
All right, so you're not. It's not what they have here in New York, where they showed like some of the areas using an open pit system.
We are not using open pit in our processes in the northern Marcellus.
All right, so basically, everything's closed. It's contained.
That is correct.
Is the regulations in Pennsylvania sort of less restrictive than they will be in New York, as far as because some of them call for like a double containment, so on and so forth?
It's important to note that the standards and the regulations that we have been operating as an industry in New York State have exceeded most other jurisdictions for a number of years. The proposals prior to the original SGIS draft that was put out in 2008, we were operating at a higher standard than many jurisdictions across the country in New York State under the current guidelines. When you add in the additional supplemental generic environmental impact statement requirements, we'll be at a level far exceeding anything that's even been contemplated in other jurisdictions across the country. With that said, Pennsylvania began significant development of the Marcellus about 4 years ago. They have been evaluating the process as development has increased. They have responded to what they have deemed as deficiencies in their operations, and they have responded to suggestions from industry as to how better to implement some best management practices in a either legislative or regulatory framework.
All right, so it'd be fair to say that in the beginning, then Pennsylvania was basically saying, okay, let's move forward with this procedure, but then as they're moving forward, they're seeing that certain things weren't working properly, and they implemented changes or put additional regulations on in order to to take care of any downfalls or shortcomings.
There have been a number of issues that the Commonwealth has decided that they needed to address and enhance their regulations over the last couple of years.
Have they expanded as they have done here in New York, whether it's buffer zones from specific well sites or in Pennsylvania? Do they have sort of a continuing moratorium on you can't drill within these certain watersheds, so on and so forth?
There are established buffers in most jurisdictions across the country that range in size depending on who put those buffers in place. Pennsylvania began this process a number of years ago with buffers in place. They are currently reviewing those buffers, and there is a number of bills that are pending before the legislature that would increase buffer zones.
Okay. Well, New York still is ranked higher in regulation on buffer zones, and as far as I would place New York in a category of having more things that there are buffers from. Some of the distances are greater in New York than they are in existing jurisdictions. There are a couple of buffers, to my understanding, that may be larger in other jurisdictions. Okay. So the recycling of the water, and that's something that we've heard environmental advocates talk about. We've heard other groups talk about it, that if you can do it, it's a way to go. Have you noticed in your company a taking some of the chemicals out of the equation that are added saying that these are needed. Are you seeing that more so in what you're doing in Pennsylvania, that some of the chemicals that we're actually using or what's being fracked and what's coming back, that you're able to either not use some of those chemicals or you're able to, by recycling, minimize any effect?
Well, the important thing yes, we are. And the important thing to realize is that each geological formation at which we are extracting this resource has its own complexities and requires certain additives based on the geology to produce a productive well. What we have found through our experience in the northern Marcellus is that we were able to reduce somewhat dramatically the amount of additives that were necessary to produce the well at a highly performing rate. So we've been able to go from 14 additives in our fracturing process to roughly about 6 on an average fracturing job in the northern Marcellus.
Okay, and according to DEC, those additives or those chemicals are going to be disclosed.
Yes.
Anyways,
that is one of the largest misconceptions about our industry. The fracturing fluids are disclosed in their totality to the regulatory agent under the SGIS and under the current GIS. We are disclosing those chemicals to the state of New York. They have the formulations, they have the number of chemicals. We are also publicly disclosing through a joint venture with the Groundwater Protection Council and the Interstate Oil and Gas Compact Commission, of which New York State is a member, all of the chemicals that are used in every fracturing job that we do in the Marcellus, publicly on a website called Frac Focus, where we disclose the maximum concentration of every chemical used in that process. Now, the reason for disclosing the maximum concentration is that it gives the public full knowledge of what the extreme amount of fluid would be contained in that process. But at the same time, it protects the federally protected proprietary trade secrets of the formulation that many of our service providers have asserted on their specific chemical formulations. So this way we get the maximum amount of knowledge out into the public domain without giving the exact specific chemical formulations.
Okay. But in New York, are they going to take that same approach by exempting out the proprietary interests?
In New York, all of the information in its totality will have to be provided to the agency. The agency, at that point in time, will be able to provide that information as necessary to emergency responders or other individuals that need to have the exact chemical composition.
What about facilities that are trying to treat it? They would need to know that information as well.
That information I don't have readily available, but it's something we can look into and get back to you on.
Is there something, do you utilize in Pennsylvania, that private facility that's trying to clean up the fracking water? There's a facility that just opened there recently, correct?
We are not currently, although we've been in discussion with a number of private entrepreneurs about private facilities that are either being investigated to come online or looking for details on how to build those facilities. We are currently doing all of our recycling in-house.
Okay. I have nothing further at this point. I'll pass it to Senator Gallivan.
With your recycling program and reuse program, do I understand correctly that from your testimony that whatever waste there is limited to solids? So you have no liquid waste that gets transported off of your site?
That is correct. We are maintaining the fluid for additional fracturing jobs following that initial processes.
How much additional water do you need? You've indicated that you're reusing 100% of your liquid after you're removing certain contaminants out of it, but then you need to add some fresh water to the process.
Correct.
Can you put that in percentage terms?
Yeah, the top end right now that we're able to reuse recycled water in a new fracturing job, we're using about 20% recycled water and about 80% fresh water. That is the current mixture that is required to effectively do the next fracturing job. We hope to be able to continue to refine the process and maximize the amount of recycled water that we're using in additional fractures. But it's also important to remember that we're getting a smaller percentage of that water return between 10 and 18% returned water, so we are always going to be at a deficit of recycled water for additional fractures.
Okay, thank you.
Good. If you guys are doing 100% recycling, have new figures been sort of estimated then on how much new water won't be necessary because of the fact that you're doing 100% recycling?
Well, we've recycled 83 million gallons of water thus far in the northern Marcellus. So that's 83 million gallons of water that we did not source for additional fractures.
And I take it if it's a 30-year well, that could be a huge amount of water that's actually saved.
Well, at this point in time, we don't anticipate refracturing the wells. We are, based on the production of the wells off an initial fracturing job, we don't anticipate having to come back and refracture those wells.
Okay. All right. I appreciate your testimony. Thank you very much.
Thank you.